Next, madam. Second slide. Move to next slide, madam. Okay. These are the impact of, okay, madam. Impact of green revolution in agriculture. Second slide, madam. Previous. Second. Next slide. Next slide, madam. Is it audible, madam?
Audible, sir. Audible.
Next
Yes, it
slide.
is audible, sir. And now it is impact of green revolution, right?
Yes. Organic farming. Okay, madam. Next.
Should I move to next?
The next, madam.
Which slide?
Impact.
Which number of?
Okay. Impact of green revolution and conventional agriculture. You know, previous slide, madam. It will affect the soil health and soil productivity. Previous slide, madam. Third slide. And it will affect biodiversity of crops and other species. Next slide, madam. Affected health of human and animal population, affected environment and social aspects, affected economic status. Coming to organic farming, you know the definition of organic farming. Organic farming is a system which avoids or largely excludes the use of synthetic inputs. Such previous slide, madam. Okay. Such as fertilizers, pesticides, hormones, feed additives, and to maximum extent possible rely upon crop rotations, crop residues, animal manures, off-farm organic waste, mineral grade rock additives, biological system of nutrient mobilization, and plant production. This definition is according to United States Department of Agriculture. Next slide. Coming to organic sources of nutrients, move to next slide, madam. There are farm manures, NADF method of composting, compost, biogas slurry, vermicompost, use of oil cakes, and by growing green manure crops, liquid manures, biofertilizers, fresh mud, coir pith composting, urban and rural garbage, and industrial wastes. Coming to liquid organic manures, liquid organic manures are the extracts obtained during the process of decomposition or fermentation of organic matter or during the process of partial or complete composition. Next, coming to comparison between solid versus liquid organic manures. Solid organic manures required in huge quantities, whereas in liquid organic manures required in less quantities. Solid contains less amount of nutrients. Liquid contains more concentrates of nutrients. Solids having nutrients are not readily available, whereas liquid nutrients are readily available to the plants. Solid organic manures no flexibility in application, whereas liquid organic manures they are having flexibility in applications. By applying solid organic manures, you cannot control the diseases, no disease depression. But by liquid organic manures, there is some disease suppressions by using some cow urines and other organic liquid manures. For solid organic manures require large space required to store, whereas in liquid organic manures you require less space required to store. Here you invest huge transportation cost in solid organic manures. There is no transportation cost in liquid organic manures. Next slide. Coming to vermiculture. Next slide, madam. What is the definition of vermiculture? Next slide, please. Vermiculture is the culture of earthworms. Vermicompost is a method of preparing compost in which earthworms are used to convert organic materials into a humus-like compost. Coming to earthworms history, according to the Aristotle, described them as the intestines of the earth. Silopatra declared earthworms scared and established laws to protect them. Charles Darwin demonstrated they improved soil and plant productivity. Next slide, madam. Coming to concept of vermicomposting. Why vermicomposting is required? The worms do the work for you. They act as a turners, like the flows worms work throughout the material. Mixers, worms move all kinds of organisms and nutrients throughout the compost pile, adding many small aggregates. They control pathogens and they act as a accelerators. They act as a screeners and even they act as a aerators. This is the concept of vermicompost. Next, you know there are earthworm species. There are nearly 3,600 to 4,000 types of earthworms in the world, and they are mainly divided into two types. One is burrowing and another type is non-burrowing. The burrowing types live deep in the soil. On the other hand, non-burrowing types convert the organic waste into vermicompost faster. The earthworm species commonly used in vermicomposting are Isenia foetidea, red earthworms, Udrilus eugenia, African earthworm or night crawler. This is extensively used in our country. Perinax excavators, composting earthworm. Next slide. Worm facts. Over 4,000 species. Larger ever found earthworm is 22 feet. Smallest earthworm is half inch. As shown in the picture, this is about 10-foot height. Next. 10-foot length of giant gypsland worm. Coming to the next slide, madam. Basic characteristics of earthworms suitable for vermicomposting: should have high rates of consumption, digestion, and assimilation. It should have high adaptability to varying environmental factors, etc. And soil temperature should not exceed more than 35 degrees centigrade. There should not be any stagnation of water for more than 45 days. Should have feeding preference and adaptability to wide range of organic materials. It should have high growth rate. It should have compatibility with other worms. Should have disease resistance. Should have least inactivity period. Time taken for earthworm for feeding after introduction. Life cycle of earthworm. Vermiculture is culturing of earthworms. Earthworms effectively harmless. the beneficial soil microflora, destroys pathogens, convert organic waste into valuable products known as cast, which contains biofertilizers, vitamins, enzymes, antibiotics, growth hormones, and proteinaceous worm biomass. Hence, earthworms called as artificial fertilizer factories. Earthworm is nocturnal in habit, clitellum adult stage. Two adults meet and lay eggs within a week. Eggs are of coriander shape. Earthworm take microorganisms through the food. Microorganisms multiply in the intestine of earthworm and they come out with the casts. It contains various types of bacteria, actinomycetes, enzymes, vitamins, and micronutrients. Next slide. Coming to preparation of vermicompost, the minimum pit size is 10-meter length, 1-meter height, 0.3-meter depth. In irrigated area and heavy rainfall areas, the vermicompost unit should be constructed above the ground. In a low rainfall area and other area, you can construct the vermicompost even in surface land in a plain area. Initially, first layer should be covered with hard crop residues like coconut and aracanut materials, which is having higher water holding capacity. Then subsequent layer, you can add the any agriculture waste. After adding agriculture waste, you should spray the dung slurry every regular interval in every stage. While adding, there should not be any mix of soil or thorning materials, glass pieces. It should be take care of. Before adding any crop residues, the crop residues like weeds and other things, they should not be flowered or seeded. You should take utmost care while adding the pit. If you add, even you can add the parthenium also, but it should be cut before the flowering. And also weeds also you can add. There should not be any soil adhere to the roots. Like that, leverois you should add and heap above the pit. And after covering with some soil or dung, regular interval, you should spray the water. After 3 to 4 weeks, after adding biomass, it will level the pit. Then you should make the holes in order to evaporate the, in order to reduce the temperature. After partial decomposition, per pit you can add about earthworms of about 2 to 3 kg. Then you can leave the earthworms. After leaving earthworms, you should cover the pit by any paddy straw or coconut fronds or aracanut fronds. There should not be any ants or any types of harmful insects should not be entered into the pit. You should always keep the pit moisture at the rate of 50%, and average you can add 50 liter per pit during summer, twice a week during the rainy season, and provide the shade to the pit. There should not be any stagnation of water in the pit. Next, madam. Vermicompost production is seen after 45 days of leaving worms to the pit. It will complete within 3 months. Residues will be converted into vermicompost. To collect, take vermicompost from the pit, leave the pit without watering for about 3 days. Worm will move to deeper layer due to lack of moisture in the upper layer. Take out the compost from the upper layer and sieve the compost and store it in a gunny bag under shade. And about 2 to 4 vermicompost will be produced from 2 to 4 ton vermicompost will be produced from 1 gunta area in 3 months, and 6 to 12 tons vermicompost will be produced from 1 gunta in 1 year. Earthworm complete their life cycle within 19 days, by which time they multiply about 40 to 50 times. In vermicompost, eggs, nymphs, and adults, all forms and all stages are found. Next. Coming to enemies of earthworms, termites, ants, rats, centipedes, frog, birds, pig, etc. Termites are main enemies. Control by simple method is by all along the vermicompost pit you can spray the chlorpyrifos, and you can on the top of the pit you can store the water, some creating some passes. Maintain 40 to 50% moisture in the pit for controlling termites, ants, and rats. Plant turmeric plants around the pit. Open small trench around the pit and put biostin powder in it. Next. Coming to vermicompost, it is also one of the important organic liquid manure. It has many beneficial effects. It will act as a organic liquid manure and plant growth promoter, and also even it act as a repellent for many insects, harmful insects. Next. Preparation of vermiwash. Next, madam. Some of the experiments conducted on onion, effect of liquid fertilizers and their efficiency on by simple experiment. By duration is 72 hours. C means control. V means they have used vermiwash. E means farm manure, I think. E. And P means panchagava and their combinations. In that, compared to control, all the organic liquid manures have the better rooting habits in case of onion. They have more effective role in growth of onion crops by using the organic liquid manures. Next. Next, madam. And coming to physical chemical properties of vermicompost. Physical parameters, pH, it varies from 6.5 plus or minus 0.01. EC, electrical conductivity, 12314 plus or minus 1.45. Chemical properties, total nitrogen 0.26 to plus or minus 0.008. Total phosphate 0.53 plus or minus 0.01. Potassium 0.292 plus or minus 0.003. It contains all the nutrients up to 13 elements it will have in the vermi wash. Next, coming to effect of different raw materials on nutrient composition of vermicompost. They have source of vermicompost by using grasses. Organic carbon percentage is 7.15%, nitrogen 0.73, CN ratio under control 30, and in vermicompost 9.49, control it is 3%, I think. Vermicompost CN ratio 9.49, even hydrogen percent 1.229, sulfur percent 0.138. If you use neem leaves, organic carbon 31.4%, nitrogen 2.145%, CN ratio in control 40%, whereas in vermicompost 14.62%, and hydrogen percentage 4.742 and sulfur 0.36. Again, if you use sawdust, organic carbon percentage 26.56%, nitrogen percentage 1.497, CN ratio in control 32.5%, whereas in vermicompost 18.16%, hydrogen percent 3.83, sulfur percent 0.3. This shows significant different values between different treatments are marked by the lowercase letters. It means by use of different source of materials used for preparing vermicompost, they will have high rate of organic carbon percentage, and it will reduce the CN ratio of the vermicompost, and also they have the better content of the hydrogen and sulfur content, and also NPK content in the different sources of raw materials used for vermicompost. They will have the NPK content. Usually for vermicomposting, if you use cereal residues, they will have high N content. If you use if you residues, crop residues, if you use the pulses, they will have the more content of P and K. It depends on the content of the straw materials used for the vermicomposting. Their nutrient content also varies. Suppose if you use the hard materials like paddy straw or coconut straw or arecanut straw and even coconut shell husk, they will have more of lignin content. Their vermicompost also rich in the lignin content. Next. This research is done by Delhi University, Rachna and Kapil et al. 2021. Next slide. Effect of vermicompost on plant growth and development. By applying vermicompost, we can see the rhizosphere root growth. There will be gravitropism of roots, axons, stomatal closure, leaf senescence, bud dormancy, and osmotic regulation of abscisic acid, increase in the shoot growth and plant biomass, and also differentiation of cells, stimulates stem elongation, determining sex expression, and promote flowering by gibberellins, promote cell division, growth of young fruits, and lateral growth by cytokinins. This study was conducted at Italy by Sami et al. 2023. Next slide. ಹಿಂಗ್ ಮಾಡ್ಬೇಕಪ್ಪ. ಹೆಂಗೆ? Coming to mechanism of disease suppression in plants using vermicompost and its derivative. Vermicompost boosts microbial diversity and activity in the rhizosphere. These microbes protect plants by inducing systemic resistance against phytopathogens, increasing nutrient competition, releasing specific metabolites against pathogens, and directly parasitizing the phytopathogens through various mechanisms. Mechanisms of disease suppression, competition, antibiosis, hyperparasitism, induced systemic resistance. Antibiosis, producing specific metabolites and antibiotics by interacting with pathogens. Trichoderma aragonum, a fungus in wormy tea produced acid antagonistic to pathogen agents. Like that, in many way it will help with hyperparasitism. Microorganisms colonize the pathogens, which leads to their death, and chitinase genes of trichoderma species in compost get activated, parasitize Rhizoctonia solani by secreting enzyme chitinase, induced systemic resistance. A resistance mechanism in plants that is activated by infection. Anthracnose in pepper and cucumber, mediated by compost extract using ISR. This study was conducted by same in Italy by Sami et al. 2023. Next slide. Comparison between, next slide please madam. Next slide. Comparison between vermicompost treated plants and normal soil plants. Height of the plant in centimeter. Ladyfinger, chili, bitter gourd, brinjal. In all the crops, by using vermicompost, they have the higher plant growth compared to normal soil plants. This study is conducted in Chennai by Imtiazam and Ramesh 2021. Next slide. Effect of FIM, NPK, vermicompost, and 50% vermicompost supplemented with 50% NPK on yield components of gingerly, sesamum indicum at 80 days. Here, this study was also conducted at Chennai by Vasant et al. 2020. Here, yield components like pod length, pod weight, number of seeds per pod, number of pods per plant, seed yield per plant, and test weight 1000 seeds weight. Compared to control, the
बुलाएं दीदी, आइए आप भी ज्वाइन करिए, स्वागत है। ये वो सब 75 बार बोले हैं। लास्ट में हमारी टीम में से करते हैं, प्रीति को लास्ट में पूछ रहा है, वो भी खेल रही है क्या? हाँ, हमारी
vermicompost, and in this case 50% vermicompost supplemented with 50% NPK has got very good result compared to all other treatments. Next slide, madam. Next slide. Benefits of vermicompost. It contains NPK, nitrogen 0.8, P 1.1 and potash 0.05%. It contains micronutrients like magnesium, iron, boron, molybdenum and zinc. They are and even growth regulators and some of the beneficial microorganisms. Thereby it increases the water holding capacity of the soil. It increases the aeration in soil. Mainly it decreases the salinity and increases the availability of nutrients, reduces the soil erosions and decreases the cost of cultivation, and there will be reduction in the incidence of disease and pests, ultimately increases the yield without affecting the any fertility status of the soil. Thank you.